Okay, so today I'm going to talk about glass transition and melting of polymers. So for amorphous polymers, there is a glass transition temperature at which the polymer changes from amorphous to viscous. So in this diagram here, there's an increasing temperature, and let's put the glass transition temperature right here. So at temperatures below this glass transition temperature, the polymer is glassy, and once the temperature is above this glass transition temperature, it is rubbery. And in the glassy region, this means that the polymer is stiff and amorphous. And in the rubbery region, this means that the polymer is viscous and soft. It's important to note that the glass transition temperature is not a fixed value, and that this value can change depending on the rate that the temperature is being changed while the glass transition of a polymer is being measured. The glass transition temperature is also not just for non-crystallizable polymers. It can be found on any polymer that is cooled enough below its melting point without crystallization that this amorphous structure is formed. For crystalline polymers, there is a melting temperature, at which point the polymer goes from solid to liquid. Semi-crystalline polymers can have both a glass transition temperature and a melting temperature. Let's take polyethylene for an example. So polyethylene has a glass transition temperature of about negative 120 degrees Celsius and a melting temperature of around 140 degrees Celsius. The structure of polyethylene includes both the crystalline region and amorphous regions. So in this diagram here, you can tell the regions with the packed chains are crystalline, and then the regions without the chain structure, where it's just kind of a coil, is the amorphous region. So if we put this on a diagram, let's put the glass transition temperature here and the melting temperature here. So below the glass transition temperature, the polymer is both glassy and crystalline. Once the polymer is above the glass transition temperature but still below the melting temperature, the amorphous part of the polymer becomes viscous, but the crystalline part stays the same. So this will be viscous and crystalline. And this is especially interesting because for polyethylene, this is at room temperature. And so the amorphous part of the polymer is liquid, while the crystalline part of the polymer is still solid, which gives it a lot of very interesting properties. And now above the melting temperature, the crystalline part becomes liquid, so the whole polymer is now viscous and liquid.